What if the smartest thing science ever did was something a Greek philosopher figured out without a single piece of equipment 2,400 years ago? And what if some of our most celebrated modern theories, the ones taught in universities, the ones that won Nobel Prizes, quietly cracked under their own weight? That is not a conspiracy. That is history, and it is far stranger than anyone tells you. Number 1. The atom was already discovered and then forgotten for 2,000 years. Here is what your textbooks probably skipped. In 400 BC, a Greek philosopher named Democritus proposed that all matter was made of tiny indivisible units. He called them atomos, which literally means uncuttable. He had no microscope, no lab, no funding. He figured it out by asking a question almost nobody else was asking. If you keep cutting something in half, what is the absolute smallest piece you can get? His answer was radical. Matter is not continuous. It is made of discrete particles separated by empty space. And everything you see, every rock, every human body, every breath of air, is just a different arrangement of those particles. The scientific establishment buried it. Aristotle himself dismissed the idea, preferring a model based on 4 continuous elements: earth, water, fire, and air. For 2,000 years, the atomic theory essentially disappeared. Then in 1803, Dalton rediscovered it. In 1897, Thomson found the electron. In 1911, Rutherford found the nucleus. And the scientific community started calling atomic theory one of the greatest achievements in human history, which it is, except it was already there 2,000 years earlier, in the mind of a man who had no recognition during his lifetime and no grave that anyone can find today. The idea that ancient thinkers were just guessing, that myth is the first thing that shatters. Number 2, someone placed the sun at the center of our solar system 18 centuries before Copernicus. We teach the heliocentric model as a 16th century revolution. Copernicus publishes in 1543. The world changes, humanity corrects a fundamental error. Except Aristarchus of Samos had already proposed his model around 270 BC. He measured the relative sizes of the sun and moon using the geometry of lunar eclipses. He calculated that the sun was vastly larger than the earth, so much larger that it made no physical sense for the sun to orbit us. His conclusion was precise and logical. The sun is the center. The earth and other planets orbit around it. The earth also rotates on its own axis, which explains the apparent movement of stars across the sky. This was not mythology. This was mathematical reasoning built on direct observation. What happened to it? Almost nothing. It was referenced by a few ancient writers, then quietly set aside, because Aristotle's geocentric universe had become so embedded in educated thought that alternatives simply were not entertained. 18 centuries passed. Copernicus arrived, and the world called a revolution. Now here is where modern science enters with its own crack. In 1998, 2 independent teams of researchers measured distant supernovae to determine how fast the universe was expanding. They expected it to be slowing down, pulled inward by gravity. What they found broke their models. The universe was accelerating. Something was pushing galaxies apart faster and faster. Scientists named it dark energy, estimated to account for about 68% of the total energy content of the universe. And here is the uncomfortable part. Nobody knows what dark energy actually is. Nobody can detect it directly. Nobody can explain where it comes from or whether it is constant or changing over time. One of the most celebrated discoveries in modern cosmology introduced a label for something completely undefined, driving a process nobody can explain. Aristarchus would have appreciated that kind of honesty, because he knew what it felt like to point at something real that nobody wanted to look at. Number 3, ancient doctors understood something that took modern medicine decades to admit. Hippocrates wrote around 400 BC that food is medicine. He emphasized sleep, movement, mental state, and environment as central to health. For most of modern medical history, these ideas were treated as poetic philosophy, not real science. Then something started happening. Decades of pharmaceutical research began producing results that were harder to celebrate. Antidepressants were prescribed to hundreds of millions of people based on the serotonin hypothesis. The idea that depression is caused by low serotonin levels. Drugs were designed to correct it and became some of the best-selling pharmaceuticals in history. In 2022, a comprehensive review published in Molecular Psychiatry examined decades of evidence and concluded there was no convincing scientific basis for the serotonin hypothesis. The foundational story behind an entire class of medication, prescribed globally for over 3 decades, had cracked. The drug still helped some people, but the explanation used to justify their mass prescription turned out to be far weaker than anyone had publicly admitted. Meanwhile, research on lifestyle medicine started confirming what Hippocrates described without a clinical trial. Exercise reduces depression symptoms as effectively as medication in many documented cases. Sleep deprivation accelerates nearly every known disease process. Chronic stress physically reshapes brain structure. Diet directly influences inflammation, cognitive performance, and emotional stability. Hippocrates was not working with modern data. He was wrong about plenty of things too, but his core orientation, that the body heals itself when given the right conditions, and that the physician's first responsibility is not interfere, turns out to point a direction that medicine is still working its way back toward. Number 4, ancient engineers built something that modern engineers spent decades trying to understand. The Roman Pantheon was completed around 125 AD. Its dome has remained the largest unreinforced concrete dome in the world for nearly 2,000 years. Modern concrete structures typically require major repairs within a century. For a long time, the assumption was simple. Roman concrete was well mixed, carefully applied, good craft. Then researchers actually analyzed the material. Roman concrete used volcanic ash from a specific region near Naples combined with seawater. And when this mixture was exposed to ocean water over centuries, it did not weaken. It grew stronger. The seawater triggered the formation of mineral crystals inside the concrete, a compound called aluminous tobamorite, which filled microscopic cracks and reinforced the structure from within. Modern Portland cement, the concrete used in virtually every contemporary construction project, does the opposite. It degrades when exposed to seawater, which is why coastal infrastructure requires constant and expensive maintenance. The Romans did not know the chemistry. They had no concept of crystal formation at the molecular level, but through centuries of accumulated trial and error, they arrived at a formula that modern materials science spent decades reverse engineering. And the most revealing part of the story, we replaced their formula, not because ours was better, but because ours was faster and cheaper to produce at industrial scale. Now we are studying theirs again to figure out how to build things that last. Number 5. Ancient astronomers built a computer, and modern cosmology still cannot account for what holds galaxies together. The Antikythera mechanism was pulled from a Greek shipwreck in 1901, a corroded lump of bronze that nobody understood for decades. When researchers finally analyzed it properly, they discovered it was a mechanical analog computer built around 100 BC, capable of predicting solar and lunar eclipses, tracking the positions of known planets, calculating the timing of the Olympic Games, and modeling the moon's irregular orbit. It used differential gearing, a technology that historians of engineering had assumed was invented in the 16th century AD. Scans completed in 2021 revealed complexity that researchers had not yet fully mapped more than 2,000 years after the device was manufactured. This was not primitive craftsmanship. This was the output of a scientific tradition that had been observing the sky and building mathematical models of planetary motion for centuries, then encoding those models into functioning physical machinery. Now contrast that precision with a persistent problem in modern astrophysics. Galaxies rotate in a way that violates standard gravitational physics. The outer edges of galaxies spin at roughly the same speed as the inner regions, which would be impossible if only visible matter existed. The outer regions should move much slower, the same way outer planets in our solar system orbit more slowly than inner ones. The proposed solution was dark matter, an invisible substance estimated to make up about 27% of the universe, providing the extra gravitational mass needed to explain what we observe. Experiments have been hunting for dark matter particles for decades. Underground detectors, Space telescopes. Particle accelerators at CERN. Nothing confirmed. Some physicists have begun developing alternative theories of gravity that attempt to explain galaxy rotation without dark matter at all. These theories have their own problems, but the fact that they are being taken seriously signals that something in the standard cosmological model may be genuinely broken. We can predict an eclipse to the second. We cannot explain what 95% of the universe is made of. Number 6. Ancient philosophers mapped the mind, and modern neuroscience still cannot explain what a thought actually is. The Stoics developed detailed frameworks for understanding thought, emotion, perception, memory, and the relationship between mental states and behavior. Their core insight was precise. It is not events that disturb you. It is your interpretation of events. You cannot always control what happens, but you can train your response to it, reshape your habits of thought, and find stability not by controlling the world, but by controlling your relation to it. Epictetus was writing this in the 1st century AD, a former slave with no formal institutional support. In the 1960s and 1970s, psychologist Aaron Beck developed cognitive behavioral therapy, one of the most rigorously tested and widely used psychological treatments in clinical practice today. Its foundational principle, exactly what Epictetus had described, that is not a coincidence. That is independent convergence. Two minds separated by 2,000 years arriving at the same structural truth about how human psychology works. But this is not where modern science cracks. The crack is deeper. Neuroscience has made extraordinary progress in mapping brain activity. We can observe neural firing in real time, identify which regions activate during specific cognitive tasks, trace electrical signals across billions of neurons, and yet, the most fundamental question in the entire field remains completely unanswered. Why is there subjective experience at all? Why does seeing the color red feel like something? Why does a piece of music produce an emotional state rather than just acoustic information? Why is there an inside to consciousness rather than just information processing happening in the dark? Philosopher David Chalmers named this the hard problem of consciousness in 1995. And the scientific community has not made substantive progress towards solving it since. Some neuroscientists argue it will eventually reduce to measurable brain activity. Some philosophers argue it is fundamentally irreducible. Some researchers believe our current conceptual tools are simply not built to handle the question at all. We have built machines that defeat world champions at chess, generate fluent human language, perform surgery with precision beyond human hands. And we still do not know what makes an experience an experience. Ancient thinkers did not solve this either, but they refused to explain it away. They took the question seriously and built entire systems of thought around it. Modern neuroscience has occasionally tried to dissolve the hard problem by redefining consciousness as something simpler than it appears to be, and every time it does, the problem resurfaces unchanged, still unanswered. Number 7. Ancient observers read the climate across generations, and modern models keep revising their projections. Pacific Islander navigators crossed thousands of miles of open ocean without instruments, using ocean swell patterns, star positions, bird behavior, cloud formations, and water temperature changes felt for the hull of the boat. European explorers with compasses and charts could not replicate the accuracy. Aboriginal Australians maintain what researchers now recognize as one of the longest continuous records of ecological and astronomical observation on Earth, encoded in oral traditions spanning tens of thousands of years. Some of these accounts accurately describe geological events, volcanic eruptions, sea level changes, the formation of specific landmarks that occurred up to 10,000 years ago. These are not legends dressed up as science. These are observational records preserved in a format different from a journal article, but no less real in their content or accuracy. Now consider where modern climate modeling stands. Climate change is real. Human-caused warming is real. The scientific consensus is legitimate, and the evidence is overwhelming. None of that is the crack. The crack is in the stated confidence of specific projections. Model after model has produced forecasts that required significant revision as real data arrived. Not because global warming is not happening, but because climate systems involve feedback loops within feedback loops, nonlinear dynamics, regional variations that resist clean generalization, and tipping points that are extraordinarily difficult to model with precision. The scientists who build these models know this. They document the uncertainty ranges carefully. They publish the error margins. But those nuances rarely survive the translation into public communication, where projections are frequently presented with a confidence that the underlying models do not actually support. And when the specific numbers miss, when predicted timelines shift, public trust in the science itself erodes. Even when the core science remains solid, ancient observers never claimed certainty. They claimed pattern. This is what we have seen. This is what tend to follow. They built knowledge systems that were robust precisely because they were honest about their limits. That honesty, not the absence of error, is what made their knowledge durable. So here's what all 7 of these stories actually tell you. Not that ancient science was better. It was not. Ancient thinkers also believed disease was caused by imbalanced humors, that some human beings were naturally suited for slavery, that the liver was the seat of the soul. They were catastrophically wrong about enormous things. And modern science is not failing either. Modern medicine has more than doubled average human lifespan. Modern physics built the technologies running in your hands right now. Modern biology decoded the entire human genome. The real pattern across all 7 examples is something more specific. Every era that produced durable knowledge shared one trait. The thinkers who got it right stayed curious longer than they stayed certain. They held their conclusions loosely enough to update them. And they treated the questions they could not answer as the most important ones on the table. Every theory that cracked shared a different trait. Somewhere along the way, the question stopped being asked. The conclusion became the foundation, and the foundation became the thing you were not allowed to examine. The serotonin hypothesis cracked because a mechanism got treated as settled before the evidence actually settled it. Dark matter is under pressure because a label got treated as an explanation. Climate projections miss because confidence in the communication outran confidence in the models. The pattern is always the same. Certainty arrives before the evidence does, and something eventually cracks under the weight of what it promised to explain. The takeaway is not to distrust modern science and romanticize the ancient world. It is to notice what durability actually looks like. It looks like Democritus holding a question for decades with no audience. It looks like Aristarchus publishing a model that nobody would accept for 18 centuries. It looks like Roman engineers mixing concrete, but I feel without knowing why it worked until it did. Durable knowledge is not loud. It is patient, and right now, somewhere, there's probably a paper that nobody is reading, a theory that seems too strange to be taken seriously, a question that the mainstream finds inconvenient. That is where the next revolution is sitting, waiting for someone curious enough to look. If this made you see science differently, share it with someone who still thinks the old world had nothing to teach us. Because the conversation that follows might be the most interesting one you have this week. And if you want to go deeper into how scientific revolutions actually happen, how ideas survive being buried and resurface centuries later, that is exactly what the next video covers.